In this video, we will be looking at vertical projectile motion, a past paper question, the one that is represented on the screen. And you want to stay tuned for the whole video because I will be sharing important teacher tips throughout the video that will help you get full marks in this section. This is not a bad section if you know what you're doing. So let's jump right in. So first of all, this is what the question looks like. Let's read the question in its entirety, look at the diagram, see if we need to fill in any missing information. That's always the first step when you start any question in physics or chemistry. So we've got a ball that is being thrown vertically upwards from the top of a building, and they represent that on the image over here. We can see the balls being thrown upwards. They show a little arrow pointing upwards. They give me the height of the building, which is obviously going to be relevant at some point. And they say 25 meters. And the ball is thrown upwards with a velocity of 12 meters per second. Upwards, on its way down, the ball passes a door, and they give me the height of the door. And they say ignore the effects of air, friction, which we do when we do vertical projectile motion. There's no other information given on this diagram over here or in the little passageway that I can add to the picture. However, before I start the question, I will make a note of extra information that I know about because I'm dealing with vertical projectile motion, and that is the following. First of all, we will need to select a positive direction for the question. Now, what a lot of students get wrong is take a look at all the sub-questions over here. We've got 3.1, which is the definition, 3.2.1, 3.2.3, through 3.2.2. Sorry, I skipped 3.2.2. These sub-questions all include calculations. We can see 3 marks, 4 marks, and 4 marks. This is a definition, and this is the drawing of a graph. I'll speak a bit later about this, but the drawing of the graph is based off of your calculations. So even if you get your calculations incorrect, if you correctly plot your answers, whatever they are, even if your answers are wrong, onto the graph correctly, you can get 3 out of 3 for the graph. Okay. I will explain that in a little bit more detail later. But what I'm trying to say is that there are 3 separate calculations that we must do. When we do these calculations, we need to stick to the same positive direction for all of them. So you can't for 3.2.1 choose up as positive, and then for 3.2.2 choose down as positive, and then for 3.2.3 choose up as positive. It's not going to work. So the very first important teacher tip that I can give you, and when we mark final exams, this is sometimes a big issue, is that learners switch up their direction. So you need to choose a positive direction. So for this question, I'm going to choose up as my positive direction. Now that's very, very, very important because, as you should know, in vertical projectile motion, acceleration due to gravity is always 9.8 meters per second, and the direction for that is always down. Now in my question, because I chose up as positive, acceleration due to gravity is always going to be a negative. That's very important, grade 12s, and you need to sub that in as a negative 9.8 throughout the entirety of the question if you choose up as positive. So remember, acceleration due to gravity always acts downwards no matter what the object is doing. So that is true. So if I'm throwing the object up, if it's at its maximum, if it's coming down again, at every single point throughout that motion, acceleration due to gravity is 9.8 meters per second down. So because I chose up as positive, it's going to be a negative. Right. What else do I know that can help me with this question? Well, as I can see, this seems to be a motion that I will probably need to break up at some point. So I've got the ball being released from the top of the building and reaching its maximum point. That can be one piece of the motion. What do we know about the velocity when it reaches its maximum height? I hope you know that the velocity when it reaches its maximum height is 0. Now, if I look at the yellow piece of the motion, that could either be a final velocity. If I'm taking this as my initial, VI is 12 meters per second upwards, my final would be 0. But if I'm looking at a second part of the motion from here to here, then this 0 now becomes my initial velocity, and hitting the ground over here, this velocity becomes my final velocity. So breaking down the motion or breaking up the motion into different pieces is also going to be important. But I'll get into that when we do our questions. Let's take a look at our first question, which is a definition question. It says define the term free fall. Now, this is just a definition that you need to learn. These definitions are available in your exam guidelines. You need to learn them word for word. But free fall is the motion under the influence of gravity or weight or gravitational force only. Now you see how this definition is a 2 or 0 definition, which means if you say motion under the influence of gravity, you might not get your marks because you need to say only. Do you see that this entire phrase is underlined? You need to say it's motion under the influence of one of these three, you can choose, but you have to say the word only. It's only gravity or only weight or only gravitational force that's acting on an object. That's when the object's in free fall. So that's why you can see an alternative definition over here where it says the motion in which the only force acting is gravity, weight, or gravitational force. So if you leave out only, you're going to get 0. Okay, cool. Next question. So this is our first calculation question. If you see a 3 marker over here, you are probably going to get marks for your formula, blank formula, substitution, and your answer. And if it's a vector, remember you need to include a direction or you may not get the answer mark if they don't say magnitude. In this question, they want me to calculate time, which is obviously a scalar. That's time. So I don't need to worry about direction. So they want time, that is my unknown. Time taken for the ball to reach its maximum height. Now, basically, remember we discussed that that would be working with this first part of the motion. So I'm working with here to here. And we already mentioned, what was the initial velocity for this part of the motion? VI is 12 meters per second, and that is going up. And we chose up as our positive direction, so that's going to be a positive value. We mentioned that when a ball reaches its maximum height, this velocity at its maximum height is 0. And for this little piece of the motion, that would be my final velocity. So final velocity is 0. And just a tip, once again, another teacher tip, is you need 3 variables in your equations of motion in order to answer a question. If you just have 2, you do not have enough information. But think about what we said. We know VI is 12, the question gave it to us. We know VF is 0 because we're speaking about maximum height. What other variable do we always know? Because this is vertical projectile motion, we always know that acceleration is 9.8 meters per second downwards. And because I took up as positive, it's going to be negative 9.8 meters per second. So I will have to substitute it in as a negative. So grade 12, if you chose down as positive, then this VI would be negative, but acceleration would be positive. So basically in this question, VI and acceleration must be in opposite directions. They are in opposite directions, so they need opposite signs. We are looking for time. So there's my 3 variables that I know. I have 1 unknown, and now my next job is to select the correct formula. Here are your formulae, and this is obviously given on your data sheet that you will receive every single test and exam. You will notice that there's 2 versions of each formula. It's just that this one has delta x, so displacement in the horizontal or along the x-axis, and this one has delta y, or displacement along the vertical or the y-axis. Because we're dealing with vertical projectile motion, which is up and down motion, we're going to use one where there's delta y. So not this one. That's for horizontal motion. This one's for horizontal motion. That one's for horizontal motion. So we will use the ones with delta y. Now you need to select one that makes sense for the question. So we're looking for time. So our formula has to have time in it. Otherwise, how are we going to find time? So I would not use this one because there's no time in it. I can choose from the other 3. But take a look. I have VI. I have VF, I have acceleration, I want time. This one looks like a good choice for me because I have VI, I have VF, I have acceleration, I want time. This one would not necessarily be a good choice because although there's VI, so I have VI, I don't have displacement. And then there's 2 values for time here. It's t squared. You'll have to do weird things here. Same thing here. I don't have delta y. I don't have the displacement. I don't know how far it was from the top of the building to the maximum height. I don't know how far that was. Of course, I can work it out, but I don't need to in this question. I'll just be wasting time. So I'm going to use this top formula over here. VF is equal to VI plus A delta t. Please write the formula as is. Then we're going to substitute in. Remember, Vf is 0 because at its maximum height, the ball stops for a second. It's got a velocity of 0. Vi is 12 meters per second and it's upwards, so it's a positive in my case. Acceleration is always down. So in my case, it's a negative because I chose up as positive and I'm looking for time. So you take 12 over, it becomes negative 12. And then you are basically having negative 9.8 multiplied by delta t. So you'll say negative 12 divided by negative 8. And you should get your time that it takes to reach maximum height as 1,22 seconds. Now, I rounded off to 2 decimal places. You can keep it to as many decimal places as you want, because remember, the rule in physical sciences is to round off to at least 2 decimal places. So you can keep all of these if you want. Just please don't round off to 1 decimal place. That will be wrong. And please be careful. You either write your unit as a S or you can write out the word seconds, but please don't write sec. We will mark you wrong. Now, with that being said, there are multiple ways to get to the correct answer. If you have to take a look at this memo, and I showed you which paper I'm busy doing, and you look at the memo, you will see that there are several options that can be followed, several routes that you can take to get to the correct answer. You could have worked out delta y, so how far the ball traveled to go from here to here, and then after that you could have worked out the time. But in my opinion, this is the most concise way to do it. It's the shortest way to do it. I think it's the easiest way to do it, but it doesn't mean that it's the only correct way to do it. So you'll get your marks here, here, and there. Our next question is a little bit more difficult. So they want the velocity with which the ball strikes the ground. So they want essentially this velocity over here, which I can take as a final velocity if you think about it carefully. So I'm essentially looking for a final velocity. If I take that as a final velocity, I need an initial velocity. Now there's 2 ways in my mind that I would approach this question. Either I'm going to use this initial velocity that they gave me over here, but this is where grade 12s get confused. The initial velocity is given for this point over here. So Vi is given as 12 meters per second upwards. And remember, we chose up as our positive direction. We need to keep that as our positive direction. If I decide to use Vi as being 12 meters per second, you may do that. That's fine. Positive 12 because I chose up as positive. Remember, we always know acceleration. In my case, it's a negative because I chose up as positive. But if you look at that, that's not enough variables. Remember, I told you need 3 variables in order to pick one of these formulas. I only have 2 right now. I do not know how long it took from when I released the ball till when the ball hits the ground. So I don't know time at this moment. It's not given to me. However, now think carefully. What I do know is the displacement from this point over here to this point over here. Now remember, displacement, in this case delta y, it's a change in position. So it's the difference in position from where you started, your initial position, pointing towards your final position. So if I take my initial velocity as 12, I'm starting over here. I'm looking for my final velocity, which is over here. What is my displacement? Remember, displacement is from where you started, which is here, to where you ended, which is here. Okay, so started, which is here, ended, which is here. If you draw an arrow from where you start to where you end, that distance is your displacement. And do I know how far that is? Yes, I do. If I start over here in line with the building, because I took Vi as being 12, so I took that as my starting point, and I ended it over here on the ground, my displacement is 25 meters downwards. I hope you can see that. 25 meters down. And remember, I chose up as positive. That means that my displacement is negative 25 meters. I can do that. Now, if I do that, which formula would I select? Which formula do you think makes the most sense for me to select? Well, I think that this one makes the most sense for me to select. Let's see why. So if I write it, we can discuss why I think it's the best formula. Remember, we are looking for final velocity. So that's my unknown. I know my initial velocity. because I'm starting over here. So my initial velocity is 12, positive 12 because it's up. I know my acceleration, it's negative 9.8 because it's down. And I know my displacement because from where I started to where I ended, that distance over there is 25 meters down. So I can do that. Let's substitute in quickly. So VF squared, I don't know that. VI is a positive 12. My acceleration is a negative 9.8. And my delta Y is a negative 25. If I type all of that into my calculator, so if I type the entire right-hand side onto my calculator, I get 634. But remember, in this formula, VF is squared. So I need to square root 634. So I say square root of my answer, and I get 25,179. My calculator says so on and so forth. So 125,18, if I round off to 2 decimal places, meters per second. And take a look at the question. They don't say the magnitude of the velocity. They just want velocity. So what did I get? I got 25,18 meters per second. So my magnitude, the velocity, is down. As you can see, I've basically done option 1 on the memo, and you get a mark for your formula, you get a mark for substituting, and in this case they were quite nice. They gave a mark for your answer, your magnitude with your unit, and for your direction separately. This is quite nice of them. Usually they join this mark, which means that if you forget your direction, they don't give you the answer mark at all. So they decided to make this question worth 4 marks, and they broke down the magnitude and the direction mark. But just remember that if they're asking for velocity, you must include a direction. If they said speed, then you do not need to give a direction. You will still use the exact same formula. You will still find VF because VF is either velocity or speed, but speed just means you don't need to give a direction. And if they said magnitude of velocity, again, it means you don't need to give a direction. But in this case, we did. Okay, we got a mark for it. And I just wanted to point out that you see here, I chose up as positive, just like option 1 in the memo. So my initial velocity is positive, but my displacement and my acceleration were both going down. Obviously, you could have done down as positive, then this would have been a negative, and both of these would have been positives. If your signs are wrong, so if you decided to make all of these negative, you would still end up with the correct answer, but you would lose this substitution mark because you do not understand the signs. That needs to be correct in order for you to get that substitution mark. Okay, now with that being said, there is a different way that you could have done this question, and basically that's as follows. You could have broken up the calculation into 2 parts. So you could have used your VF over here, that's your unknown, as we've mentioned. You could have used VI as 0. That's fine. That would mean that you are working with this part of the motion, which is perfectly fine. So remember, in my option, what I did, my option 1, I worked with this part of the motion, this green part. That's why I could use the 25 meters as my displacement. But you could work with this yellow part of the motion. VI would be 0 here because you're starting where the ball is at its maximum height. You're ending here, you're looking for that. Acceleration would still be negative 9.8 meters per second, but then you would need one more variable. And that variable would probably be displacement, so delta Y. And in order to get delta Y, you would have to work out how far this little piece is. This little piece over here. Because we know that from here to here is 25. But we need this entire piece. Okay, so we know that this is 25, but I would need to work out what this is and then add it to 25 to get the entire displacement. And in order to do that, I would need to use the previous information. So I would need to do a side calculation where I use VI as being 12, VF as being 0, my acceleration as being negative 9.8, and then I would use this formula and I would substitute in my VI as being 12 because I'm starting here. My VF is being 0 because I'm ending here. Remember, I'm trying to find this distance over here, or this displacement. My acceleration is down, and so on. When you solve for delta Y, you will end up getting delta Y as equaling 7,346938776 meters. I'm not rounding this off because this is not the end of my question. If I decide to do this option, just take note that that delta y is this green piece over here. So therefore, what that means is this entire yellow distance would be 25 plus 7,3469 dot dot dot, and that would be 32,3469 dot 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 meters. And again, why do I care in this option about how far the yellow distance is? Well, that is if I decide to work out VF at the bottom by starting here with VI being 0 at the top. So it all depends on which option you use to find your answer. So if I use VI as being 0, I'm starting up here. I'm looking for VF, I'm ending down here. Acceleration is going down, it's negative 9.8, and my displacement, delta y, is starting here and ending here. It's going down, and it's 32, so negative 32,3469, and so on, meters. When using these variables, I can substitute it into my formula, and I'll get the same answer as that I got when I did option number 1. Let me show you quickly. There we go. As you can see, you get the same answer. It might differ slightly by decimal or two, and in this case it doesn't. It's 25,18. That's what we got when we used our first option. And this is option 3 according to the memo, 25,18 meters per second downwards. As you can see, your acceleration and your displacement must have the same direction and therefore the same sign in this option. And you can see here that the memo says it's from B to G. So they started from B, they ended at G. Okay, cool. Right, grade 12s, this last question is quite a challenging question, so try and follow me as best as you can. To make it a little bit easier, I have this diagram over here which represents the different points in the ball's motion, and I just wanted to show you how it corresponds to the picture over here. So A is the top of the building, B is the maximum height of the ball, C is again the top of the building but on the way down, D is the top of the door, and G over here is the bottom of the door or the ground. Okay, so first things first, the velocity of the ball at A when the ball is released from the top of the building is 12 meters per second upwards. So it's a positive. Remember, we chose up as positive. At B, the velocity of the ball is 0 because it's at its maximum height. At C, which is in line with the top of the building, again, it's in line with A, the velocity of the ball is 12 meters per second down because it's in line with A, and remember time symmetry in vertical projectile motion, so it's at the same point in space, so A and C are on the same level, but A is going up, so 12, positive 12 because up is positive, and C is going down, so negative 12. Okay, I hope that makes sense. D is the top of the door. We do not know what the velocity of the ball is at the top of the door. And G is just as the ball hits the ground. We just worked that out. Negative 25,18 meters per second. Now remember, I'm just saying negative because it's indicating direction in this case. So the ball's going down as it hits the ground, and we chose up as positive. Now what the question wants is the time that it took for the ball to move from the top of the door, so from D, to the ground, which is G. Now, there's a lot of different ways, once again, to do this question. There's often a lot of ways to do a question in vertical projectile motion. Memos can have 12, 13, 14, 15 options, which is absolutely crazy. It just shows you that there's a wide range of possibilities. I'm going to show you the one that makes sense to me, and hopefully it will make sense to you as well. So if I'm looking for the time it took for the ball to move from the top of the door to the ground, I think it makes sense to work with this piece of the motion. Just that little piece over there. From D to G. From D to G. What's nice about that piece of the motion is that we know delta y. So we know the displacement for that piece of the motion. How far is it from the top of the door to the ground? They tell you on your diagram. 1,9 meters downwards. And remember, we chose up as positive, so it's going to be a negative 1,9 meters. I know that acceleration is always down, so it's negative 9.8 in my question because, again, I chose up as positive. Now, what I do know is that I know that the final velocity is negative 25,18 meters per second. So I know that that is VF. Negative 25,18 meters per second, because I told you guys I'm taking, this is my starting point, this is my ending point. But what is my initial velocity for this little piece of the motion? I don't know. I don't know what the velocity is of the ball when it reaches the top of the door. I know over here it's negative 12. So it's going to be, more than 12, but less than 25. I don't know what it is though. And I kind of need that in order to work out delta t for this part of the motion. Reason why is, let's look at my formulas quickly. Remember, in my question, I'm looking for the time that it takes for the ball to go from the top of the door to the bottom. So this equation has time in it, but I need VI and VF in order to use this equation. This equation does not have time, so it's not going to work. This equation has time, but it needs VI in order for me to use it. I don't know VI yet. Remember, looking at my picture, I don't know VI if I'm using this as my little piece of my motion. This would be VI, this would be VF. I know VF, I don't know VI. Back to my equations. Again, this one needs VI and VF. It has time, but it needs both of them. So, step one, in order for me to find time, so this is my ultimate goal, I first need to find VI. And how am I going to do that? Well, if I'm looking for VI, I have delta y to get from here to here. To get from here to here, it's 1.9 meters. So I know that. I know acceleration and I know my final velocity. So I can find VI by using the following equation. VF squared equals VI squared plus 2a delta y. Again, VF squared, negative 25,18 squared. VI squared is what I'm looking for. Acceleration, negative 9.8. And delta y is negative 1,9. Please remember grade 12s that it's negative because the ball is going from here downwards. Acceleration is negative because it's down. This is very, very, very important. So take your calculator out. Do it quickly with me. I'm solving for VI. I get VI squared as equaling that. And then as you know, you must square root both sides. So I get VI over here to be 24,42933,483 meters per second. Okay, cool. I'm not bothered about rounding off. You actually shouldn't round off. We're not at the end of the question. I'm not bothered about a direction because, again, I'm not at the end of the question. But what I want to highlight, what's very important, is the fact that I now know the velocity of the ball at point D, which is 24,429 ... I'm saying ... because I'm not rounding off, meters per second. Right. So I know the velocity at the start of the door. I know the velocity at the end of the door. If you take a look at your picture, I know the velocity here. I know the velocity here. I know the displacement. I know the acceleration. So I can find the time that it takes to go from here to here. That's basically what we're doing. So these are my variables that I currently know. Remember, we're working with the door, so I know the initial velocity at the start of the door. I know the initial velocity at the end of the door. I know everything that I need to know. Take a look at how they're all negative. That makes sense because I chose up as positive. And think about the door in the picture. The ball is coming downwards. Here's the start of the door. Here's the end of the door. So the ball's coming downwards. The velocity at the start of the door is downwards. The velocity at the end of the door is downwards. Acceleration is downwards. Displacement is downwards. The ball is falling down. So everything here is negative. I'm going to use my first formula. Remember, I'm looking for the time that it took to go from the start of the door to the end of the door. There's everything. Final velocity, negative 25,18. Initial velocity at the top of the door, negative 24,429,334. Remember, don't round that off. We're not at the end of the question. Acceleration, negative 9.8. And therefore, we are working out time. If you do that correctly on your calculator, you will get 0,07659 and so on. I'm going to round it off to 2 decimal places because I'm now at the end of the question. It's 0,08 seconds. Now, as I mentioned, there's a lot of different ways to do this. That's just the way that I decided to do it. You can go and have a look at the memo to see if there's perhaps another way that you like to do it. But our very last question, let me show you where you get your marks for this question quickly. So you would actually get your first mark of this question for working out what the velocity is at this point over here. You need it. You couldn't have done the question without it. You need that velocity over there. So you get 1 mark for working out what that velocity is at that point. Whichever method you choose to do it, as long as you do it correctly, you get the mark. Then you get a formula mark over here, a substitution mark, and an answer mark. It's 4 marks again. You will only get this substitution mark if your signs are correct. All of these must be negative, okay, because it's going down. And I chose up as positive. Or if you chose down as positive, all of them must be positive. Right, let's draw the graph. Now, drawing the graph is not supposed to be difficult because you use your previous answers in order to draw the graph. And what's nice about these questions is they tell you exactly what type of graph that they want, a velocity versus time graph. So we know we are going to plot like this. Velocity on the y-axis, so write velocity and give me the unit, meters per second. Then we're going to have time, give me the unit in seconds. And they say, draw the velocity versus time graph for the motion of the ball from the moment the ball is thrown upwards. So that's basically from the beginning of the motion, where VI is 12, until it hits the ground. Remember, when it hits the ground, we worked out the final velocity is negative 25, something. I'll fill it in now. Use the ground as the 0 reference. Okay, cool. Clearly indicate the following on your graph. What's nice is they tell you exactly what they want you to put on the graph. It's 3 marks, so it'll probably be 1 mark for each of these. First of all, the velocity with which the ball was thrown upwards. Now remember, again, I chose up as positive. You can't change it now. I must keep up as positive. The ball was thrown with 12 meters per second upwards, so it's going to be a positive 12. So I indicate over here on my graph, positive 12. That's your initial velocity. So that, the velocity with which the ball was thrown upwards, that is that on my graph. Great. The time taken by the ball to reach its maximum height. We worked that out. So we can go to our questions over here. Remember we said that it takes 1,22 seconds for the ball to reach its maximum height. So what we do is on the graph, we go to that 0 seconds. Let's say this over here is 1,22 seconds. Now think about this, grade 12s. What was the velocity of the ball when it reached its maximum height? Remember, you need to learn that at its maximum height, the velocity of the ball is 0. So we're going to draw a dot here on 0 velocity. So took 1,22 seconds. That's why my dot is on 1,22. And read to the left, my velocity is 0. We'll join the dots now, but let's just carry on. So that the time taken by the ball to reach its maximum height, that's that. And then lastly, the velocity with which the ball strikes the ground. That's all you need to indicate for me. And we worked that out quite a while ago. We worked that out over here. 25.18 meters per second down. Remember, I showed you the memo as well. 25.18 meters per second down. And because we chose up as positive, that is going to be a negative 25.18. So that's going to be down here. Somewhere here, negative 25.18. And obviously it's going to be at a much later time. Okay, so we're going to draw the dots somewhat like that. Okay, just draw dotted lines to show me that that dot matches up with that velocity. And then we join our lines. So I obviously want you to use a ruler. I don't have a ruler right now, so I'm going to just do my best with what I have. Your line should be a straight line. Your line should actually end there. So your line should be a dead straight line, like that. And why do you think that your line should be a dead straight line? What does the gradient of this graph represent? I hope you know that because it's a velocity versus time graph, so velocity divided by time would give me the gradient. That is the acceleration. So the gradient of this graph is the acceleration, and acceleration is always constant. It's 9.8 meters per second downwards. And in our case, it's a negative 9.8, and you can see that the gradient is a negative gradient. So you'll get your marks there, there, and there. If your line is not straight, they will minus marks. If your line is not decreasing, if it's going up and then down and then doing weird things, they will minus marks. So here's the memo, and this is exactly how they mark it. That's exactly the same graph that I drew. I just wanted to show you how nice and straight their line is. You can show me where you've plotted your points like that. And this is the criteria for the graph. So straight line, so it has to be a straight line, can't be wonky or skew or wobbly. And it starts here. So that gets you 1 mark. So if you don't start at 12, and it has to be 12 because they gave that to you in the question. You can't start it anywhere else. Has to start at 12, and if it's not straight, you're not going to get that mark, obviously. Straight line cuts the time axis at the time calculated in question 3.2.1. So we calculated it as 1.22, but if you calculated it as 1.65 or whatever, say you got it wrong, as long as you plot that, whatever you got on the graph, on this x-axis over here, you will get that mark. So it is positive marking. It's called CA marking or positive marking. And correct final velocity that you calculated in 3.2.2, you plot over there. It obviously has to be a negative. Right. If you chose down as positive, so this is how your graph will look. If you chose up as positive, if you chose down as positive, this is how your graph will look. Same points, except if you chose down as positive, your initial velocity is going up, which would make it negative. Your final velocity is going down, which would make it a positive. It's kind of like a mirror image of the previous graph. Your time would still be on the x-axis, 1.22, or whatever you calculated. I hope that was a helpful question. Please let me know in the comments if you want to see any more vertical projectile motion questions, and I'll see you guys in another video. Bye, everyone.